Welcome to Cloud Cookie Academy. In this video, I will walk you through a demo of our IoT data analytics platform. If you've ever shopped at a supermarket, you might have noticed a request to take a survey at the bottom of your receipt. How often do you fill out those surveys? Introducing XPRESS, a customer satisfaction terminal that aims to improve survey data collection. This solution consists of a set of customizable buttons, a receipt printer, and a management dashboard. It also has an expandable functionality, such as a call button. Let's begin with the Management Dashboard web client. Identity and access management limits user access to our dashboard. Log in with username and password. The dashboard sidebar on the left displays two functions. The user profile and refresh button are on the top right corner. Here is a floor plan of a sample retail store, the locations of call buttons illustrated as an animated bell icon. The bell icon rings when the buttons are activated. The store associates and store manager can log in to view and clear the call queue on their smartphone or computer. Another main feature is an analytics dashboard. Our current product integrates Tableau dashboard into our web client. This dashboard is created with dummy data on Tableau desktop. Let's see how data collected from the terminal reach the dashboard. Now, let's dive into our software design. We will begin with an overview of an architecture diagram. The hardware components of the terminal consist of a series of Flick Smart buttons, a RaspberryPi, a receipt printer, and a display panel. SORACOM network connectivity. AWS infrastructure consists of IoT core, Lambda functions that ingest data into a PostgreSQL database. Dashboard pulls data from the database. CloudFront delivers content to web and mobile clients. AWS IoT Core is a managed cloud service that lets connected devices easily and securely interact with cloud applications and other devices. AWS IoT Core can support billions of devices and trillions of messages, and can process and route those messages to AWS endpoints and to other devices reliably and securely. Let's look into the RaspberryPi IoT thing. Devices connected to AWS IoT are represented by things in the AWS IoT registry. A thing represents a specific device or logical entity. AWS IoT provides a registry that helps you manage things. A thing is a representation of a specific device or logical entity. It can be a physical device or sensor, for example, a light bulb or a switch on a wall. It can also be a logical entity like an instance of an application or physical entity that does not connect to AWS IoT but is related to other devices that do, for example, a car that has engine sensors or a control panel. Things are identified by a name. Things can also have attributes, which are name-value pairs you can use to store information about the thing, such as its serial number or manufacturer. A device must have a certificate, private key, and root CA certificate to authenticate with AWS IoT Core. Each connected device or client must have a credential to interact with AWS IoT. All traffic to and from AWS IoT is sent securely over Transport Layer Security or TLS. AWS Cloud Security mechanisms protect data as it moves between AWS IoT and other AWS services. Connected devices are constantly communicating with each other and the cloud using different kinds of wireless communication protocols. While communication creates responsive IoT applications, it can also expose IoT security vulnerabilities and open up channels for malicious actors or accidental data leaks. To protect users, devices, and companies, IoT devices must be secured and protected. A security vulnerability is a weakness which can be exploited to compromise the integrity or availability of your IoT application. IoT devices by nature are vulnerable. AWS IoT Device Defender continuously audits your IoT configurations to make sure that they aren't deviating from security best practices. AWS IoT Device Defender makes it easy to maintain and enforce IoT configurations, such as ensuring device identity, authenticating and authorizing devices, and encrypting device data. Devices on the edge can use the MQTT protocol to communicate with the AWS cloud. AWSIoT hosts an MQTT broker that sends and receives messages to and from connected devices at the edge. Next step, I will show you the Lambda function calls by a Lambda rule created in AWS IoT. This time we use Lambda functions to generate dummy click data and insert into PostgreSQL database. We have defined a Lambda function to send data from the terminal to AWS IoT using IoT rules. This allows us to extract data from the incoming message and then call another AWS or third-party service. An AWS Lambda function's execution role grants it permission to access AWS services and resources. You provide this role when you create a function, and Lambda assumes the role when your function is invoked. AWS Lambda supports resource-based permissions policies for Lambda functions and layers. Resource-based policies let you grant usage permission to other accounts on a per-resource basis. You also use a resource-based policy to allow an AWS service to invoke your function. AWS Lambda monitors functions on your behalf and sends metrics to Amazon CloudWatch. The metrics include total requests, duration, and error rates. The Lambda console creates graphs for these metrics and shows them on the monitoring page for each function. When your function finishes processing an event, Lambda sends metrics about the invocation to Amazon CloudWatch. You can build graphs and dashboards with these metrics in the CloudWatch console, and set alarms to respond to changes in utilization, performance, or error rates. AWS Lambda is a compute service that lets you run code without provisioning or managing servers. AWS Lambda executes your code only when needed and scales automatically, from a few requests per day to thousands per second. You pay only for the compute time you consume. There is no charge when your code is not running. With AWS Lambda, you can run code for virtually any type of application or backend service, all with zero administration. AWS Lambda runs your code on a high availability compute infrastructure and performs all of the administration of the compute resources, including server and operating system maintenance, capacity provisioning and automatic scaling, code monitoring and logging. All you need to do is supply your code in one of the languages that AWS Lambda supports. AWS IoT Events monitors the inputs from multiple IoT sensors and applications to recognize event patterns. Then it takes appropriate actions when events occur. AWS IoT Events receives its inputs as JSON payloads from many sources. AWS IoT Events supports simple events, where each input triggers an event, and complex events, where multiple inputs must occur to trigger the event. It creates dummy data from 9 a.m. to 9 p.m. every day, Vancouver time zone, between a predefined start and end dates, with 5 sentiment for every question of every location. The data includes metadata from Flick button, and dummy data such as table name, locations, store areas and questions. It deletes the table if needed to clear the existing data, recreates it and inserts the new dummy data. We randomize the data such that we have some clicks every hour but every day has a slightly different average sentiment. To manage a function, open the Lambda console functions page and choose a function. The function designer is at the top of the configuration page. The designer shows an overview of your function and its upstream and downstream resources. You can use it to configure triggers, layers, and destinations. In our system, the ingest button click ES Lambda function is triggered by AWS IoT action. This Lambda function ingests data into our database when the AWS IoT received button click data from the terminal. You can use AWS Identity and Access Management, IAM, to manage access to the Lambda API and resources like functions and layers. For users and applications in your account that use Lambda, you manage permissions in a permissions policy that you can apply to IAM users, groups, or roles. To grant permissions to other accounts or AWS services that use your Lambda resources, you use a policy that applies to the resource itself. Finally, let's see a demo of a dashboard created by Elasticsearch. Amazon Elasticsearch Service or Amazon ES is a managed service that makes it easy to deploy, operate, and scale Elasticsearch clusters in the AWS cloud. Elasticsearch is a popular open-source search and analytics engine for use cases such as log analytics, real-time application monitoring, and clickstream analysis. An Amazon ES domain is synonymous with an Elasticsearch cluster. Domains are clusters with the settings, instance types, instance counts, and storage resources that you specify. You can create an Amazon ES domain by using the console, the AWS CLI, or the AWS SDKs. When the new Amazon ES domain initialized, make note of its endpoint. It is used for uploading data to Amazon ES domain for indexing. Indexing is the method by which search engines organize data for fast retrieval. You must index your data before you can search for meaningful data. The resulting structure is called an index. In Elasticsearch, the basic unit of data is a JSON document. Within an index, Elasticsearch identifies each document using a unique ID. We use the access policy to manage user access to our Kibana dashboard. Since allowing public access to our ES domains is not a best practice. In order to protect our domains against unauthorized access, we configured Amazon Elasticsearch Service access policies to allow several admin computers with resource-based, IP-based and IAM user or role-based policies to view and send data to ES. You can also import access policies from other AWS ES domains. The link to access Kibana is listed on the domain dashboard on the Amazon ES console. It usually takes a couple of seconds to access Kibana from the AWS console. Kibana is a popular open-source visualization tool designed to work with Elasticsearch. Amazon ES provides an installation of Kibana with every Amazon ES domain. In Discover, you can find all of the document in every index that matches the selected index pattern. The index pattern tells Kibana which Elasticsearch index you are currently exploring. In this page, you can submit search queries, filter the search results, and view document data. The histogram on the top shows the distribution of documents over time. The table below lists the fields for each matching document. By default, all fields are shown. We can go to the left panel to add or remove the fields displayed on this Discover page. The official Kibana documentation on elastic.co provides more information and a Get Started guide on this data visualization tool. Our solution can integrate different data analytics platforms, and the dashboard layout is customizable according to the client's needs. You can choose from Tableau, Kibana, AWS QuickSight. You can also choose to display data in pie chart, line graph, bar chart, heat map. The parameters in the graphs can be customized to clients' preferences as well. Let's look at a few examples of our graphs. The bar chart is a simple vertical bar where y-axis is defined under metrics and x-axis is under buckets. In the Visualize application, you can shape your data using a variety of charts, tables, and maps. A heat map is a two-dimensional visual representation of data using colors, where the colors all represent different values. Heat maps are helpful because they can provide an efficient and comprehensive overview of a topic at a glance. Unlike charts or tables, which have to be interpreted or studied to be understood, heat maps are direct data visualization tools that are more self-explanatory and easy to read. In our dashboard, We use heatmap to show how busy a store area is during a date range. Managers can use this information to predict and allocate resources to help out in the more busy store areas. Now we are ready to create a dashboard. To create a dashboard in Kibana, you need to have data indexed into Elasticsearch, an index pattern to retrieve the data from Elasticsearch, and visualizations, saved searches, or maps. The visualizations, saved searches, and maps are stored as elements in panels that you can move and resize. We have a pie chart that shows the percentage of customer satisfaction sentiments, a bar chart showing the number of clicks per store area with color bars showing the number of sentiment, a bar chart of button clicks number per store area, a summary of clicks in every store area, a histogram displaying number of clicks per week, a list of all data in a table form. In this table, you can click on each row to display the data in table or in JSON format. The last chart is a heat map that gives an overview of busy store areas in the past 6 months. We can specify the time filter that displays only the data on the Kibana dashboard within the specified time range. By default, the time filter is set to the last 15 minutes. You can use the time filter to change the time range, or select a specific time range in the histogram. You can choose from relative, absolute time. You can also set the auto refresh frequency for the dashboard to fetch data and renew the dashboard contents. This will ensure the dashboard is up to date and the statistical data is displayed accordingly to the analysis period. Full screen mode is best for displaying on the TV for monitoring. Each of the chart can be enlarged to display a single chart in full screen mode. You can see in the introduction of this video that the Tableau dashboard displays all of the charts on a single page. This allows the manager to display the metrics and key performance indicators on a TV screen, in an office. By clearly visualizing the performance data, and drawing attention to the company's objectives, a TV dashboard improves team performance and helps to create team alignment. We can use these embedded a frame or URL linked to embed the Kibana dashboard on our management portal webpage. We can use the clone dashboard function to create a copy. Any changes made on AWS environment will be reflected on the webpage immediately. You can add charts from the visualization library onto the dashboard directly using the Add button. The visualizations, saved searches, and maps are stored as elements in panels that you can move and resize. You can add elements from multiple indices, and the same element can appear in multiple dashboards. The panel title is different than the graph's name, so we can rename the panel title displaying on the dashboard. Click on the Edit Visualization link will bring you back to the Charts Visualization Edit page. In the Option tab, you can choose to display dark theme, adjust margins between panels, and hide all panel titles. Remember to save the dashboard after making any changes. Now let's look at the other functions on the left panel. Timeline is the clawing, gnashing, zebra killing, pluggable time series interface for everything. Timeline is a time series data visualizer that let us combine independent data sources to a single visualization. An alert specifies a background task that runs on the Kibana server to check for specific conditions. The alerting feature notifies you when data from one or more Elasticsearch indices meets certain conditions. Amazon ES supports Amazon SNS for notifications. This integration with Amazon SNS means that, in addition to standard destinations such as Slack, custom webhooks, and Amazon Chime, the alerting feature can send emails, text messages, and even execute AWS Lambda functions using SNS topics. Kibana is a powerful tool to search and visualize data stored in Elasticsearch. Kibana looks for fields defined in Elasticsearch mappings and presents them as options to the user to build a chart. Kibana allows us to further edit data fields as combined fields, or user-defined fields. This is where Kibana scripted fields come in handy. An index pattern is the glue that connects Kibana to our Elastic Search data. Index management helps us to ensure that our data is stored in the most cost-effective way possible. This terminal can be modified to cater to demand of contactless alternatives, such as voice activation using Alexa, or QR code scanning. Additionally, we can also program the receipt printer to dispense tickets automatically to reduce direct contact with shared surface. We can limit the data range to analyze data at various time intervals. We can choose from relative time and absolute time. For example, we can limit the dashboard to display data from last year, last month, last week, or a specific data range. We can set refresh frequency according to the button click traffic. Now the dashboard will refresh every 5 seconds. I hope you enjoy this video and find it useful. If you have questions about our customer satisfaction analytics solution, feel free to contact us.